Welcome. Today, we are looking at magnetism. This is topic 6 in your SS2 physics series. This topic covers the properties of magnets and magnetic fields. This topic appears regularly in your examinations. Pay close attention. Let us begin. First, let me explain what magnetism is. Magnetism is the property of certain materials to attract or repel other materials. It is a fundamental force of nature. Magnetism is caused by the motion of electric charges. It is closely related to electricity. Understanding magnetism is essential for understanding electromagnetism. It is essential for understanding many technologies. Examples include electric motors, generators, and transformers. Magnetism is everywhere in modern life. It is used in speakers, hard drives, and MRI machines. Now let me explain the properties of magnets. Magnets have several properties. First, they attract magnetic materials. Examples include iron, steel, nickel, and cobalt. Second, they have two poles, the North Pole and the South Pole. Third, like poles repel. North repels north, south repels south. Fourth, unlike, poles attract. North attracts south. Fifth, the poles cannot be separated. If you break a magnet, each piece becomes a magnet. Sixth, magnets align with the Earth's magnetic field. A compass needle points north. Understanding these properties is essential for understanding magnetism. Now let me explain the types of magnets. There are three types of magnets: permanent magnets, temporary magnets, and electromagnets. Permanent magnets retain their magnetism. Examples include bar magnets and horseshoe magnets. Temporary magnets are magnetized only in the presence of a magnetic field. Examples include soft iron. Electromagnets are magnets produced by electric current. They consist of a coil of wire around an iron core. Electromagnets can be turned on and off. Understanding the types of magnets is essential for understanding their applications. Now, let me explain magnetic fields. A magnetic field is the region around a magnet where its influence is felt. It is represented by magnetic field lines. Magnetic field lines show the direction of the magnetic force. They emerge from the North Pole and enter the South Pole. They form closed loops. They never cross. The density of field lines indicates the strength of the field. Closer lines mean a stronger field. Understanding magnetic fields is essential for understanding magnetism. Now let me explain the Earth's magnetic field. The Earth behaves like a giant magnet. It has a magnetic field. The magnetic field is generated by the movement of molten iron in the core. The magnetic poles are near the geographic poles. The North Magnetic Pole is near the South Geographic Pole. This is why the North Pole of a compass points north. The Earth's magnetic field protects us from solar radiation. It creates the auroras. Understanding the Earth's magnetic field is essential for understanding navigation and space weather. Now let me explain magnetic materials. Magnetic materials are materials that are attracted to magnets. They include ferromagnetic materials. Examples include iron, steel, nickel, and cobalt. Paramagnetic materials are weakly attracted to magnets. Diamagnetic materials are repelled by magnets. Ferromagnetic materials are used to make magnets. They have domains. Domains are regions where atomic magnetic fields are aligned. In an unmagnetized material, the domains are randomly oriented. In a magnetized material, the domains are aligned. Understanding magnetic materials is essential for understanding magnetism. Now, let me explain the magnetization of materials. Magnetization is the process of making a material magnetic. It can be done by several methods. First, by stroking. A material is stroked with a magnet. Second, by hammering. A material is hammered while aligned with a magnetic field. Third, by heating and cooling. A material is heated and cooled in a magnetic field. Fourth, by electrical current. A material is placed in a coil of wire. Current is passed through the coil. This produces a magnetic field. Understanding magnetization is essential for making magnets. Now let me explain demagnetization. Demagnetization is the process of removing magnetism. It can be done by several methods. First, by heating. Heating above the Curie temperature destroys magnetism. Second, by hammering. Hammering randomizes the domains. Third, by alternating current. An alternating magnetic field randomizes the domains. Understanding demagnetization is essential for maintaining magnets. Now, let me explain the force between magnets. The force between magnets depends on the distance. It is an inverse square law. The force is proportional to the product of the pole strengths. It is inversely proportional to the square of the distance. Like poles repel, unlike poles attract. The force is transmitted by the magnetic field. Understanding the force between magnets is essential for understanding magnetic interactions. Now let me explain magnetic flux. Magnetic flux is the measure of the total magnetic field passing through a surface. It is measured in Webers. The formula for magnetic flux is phi equals BA cosine theta. Phi is flux. B is magnetic flux density. A is area. Theta is the angle between the field and the normal. Magnetic flux is important for understanding electromagnetic induction. Understanding magnetic flux is essential for understanding Faraday's law. Now, let me explain magnetic flux density. Magnetic flux density is the amount of magnetic flux per unit area. It is measured in Teslas. It is also called magnetic induction. It is the strength of the magnetic field. The formula for magnetic flux density is B equals phi over A. B is flux density. Phi is flux. A is area. Magnetic flux density is important for understanding the force on moving charges. Understanding magnetic flux density is essential for understanding electromagnetism. Now let me explain the force on a moving charge in a magnetic field. A moving charge experiences a force in a magnetic field. The force is perpendicular to both the velocity and the magnetic field. The formula is F equals QVB sine theta. F is force, Q is charge, V is velocity, B is magnetic flux density. Theta is the angle between the velocity and the field. The direction of the force is given by Fleming's left-hand rule. Understanding the force on moving charges is essential for understanding electric motors and generators. Now let me explain the force on a current-carrying conductor in a magnetic field. A current-carrying conductor experiences a force in a magnetic field. The force is perpendicular to both the current and the magnetic field. The formula is F equals BIL sine theta. F is force. B is magnetic flux density. I is current. L is length. L. Theta is the angle between the conductor and the field. The direction of the force is given by Fleming's left-hand rule. Understanding the force on current-carrying conductors is essential for understanding electric motors. Now let me explain the applications of magnets. Magnets have many applications. In motors, magnets are used to produce motion. In generators, magnets are used to produce electricity. In speakers, magnets are used to produce sound. In hard drives, magnets are used to store data. In MRI machines, magnets are used for medical imaging. In compasses, magnets are used for navigation. In cranes, electromagnets are used to lift heavy objects. Understanding the applications of magnets is essential for understanding modern technology. Now, let me explain the difference between a magnet and an electromagnet. A magnet is a permanent or temporary magnet. An electromagnet is a magnet produced by electric current. A magnet has a fixed magnetic field. An electromagnet's field can be controlled by the current. A magnet cannot be turned off. An electromagnet can be turned on and off. Electromagnets are more powerful than permanent magnets. They are used in many applications. Understanding the difference is essential for choosing the right magnet for a task. Now, let me explain the importance of magnetism. Magnetism is important for several reasons. First, it is a fundamental force of nature. Second, it is essential for electromagnetism. Third, it is essential for many technologies. Examples include motors, generators, and transformers. Fourth, it is essential for navigation. Compasses use the Earth's magnetic field. Fifth, it is essential for medical imaging. MRI machines use strong magnetic fields. Sixth, it is essential for data storage. Hard drives use magnetic recording. Understanding magnetism is essential for physics and technology. Now let me give you sample exam questions. Define magnetism. Magnetism is the property of certain materials to attract or repel other materials. State the properties of magnets. Magnets attract magnetic materials. They have two poles. Like poles repel. Unlike poles attract. Define a magnetic field. A magnetic field is the region around a magnet where its influence is felt. State the difference between a magnet and an electromagnet. A magnet has a fixed field. An electromagnet's field is controlled by current. Explain the Earth's magnetic field. The Earth behaves like a giant magnet. The magnetic poles are near the geographic poles. State the formula for the force on a current-carrying conductor. F equals BIL sine theta. Let me summarize. Magnetism is the property of attracting or repelling materials. Magnets have north and south poles. Like poles repel. Unlike poles attract. A magnetic field is the region of influence. The Earth has a magnetic field. Magnetic materials include iron, steel, nickel, and cobalt. Magnetization and demagnetization are important processes. Magnetic flux and flux density describe magnetic fields. Moving charges and current-carrying conductors experience forces in magnetic fields. Magnets have many applications. Understanding magnetism is essential for physics and technology. Practice these concepts. When you have them down, move to Topic 7.